on this computer and share the okay. This is the lab, and you can read this, but I think I'll let me stop the share and we'll just go through the through the different functions. Right now, this is in the off position, and when you're not using it, this is should be the position that it always is, and always have it off. It'll drain the battery up. Otherwise, the first set of measurements is AC voltage. You can see it has a little squiggly line above the oh no, I'm sorry, this is DC voltage. It shows a line and then a dash line underneath it. That's the you can be looking on your the file I sent. It has the same thing, DC volts. Then you go over here to AC volts. Now you have to be cautious because the AC voltage, AC means alternating current. We haven't gotten there yet, but DC is like what comes out of a battery. It's just a solid power source, whereas AC, it's alternating current. It's going back and forth. It's actually switching direction. That's what you get out of your wall, and it can measure the 60 hertz that's coming out of your wall. But I forget what the limitation is. I mean, if you're going to try to measure audio signals from using this, it's not going to work because there's a limit as to how high a frequency it can measure. So you go from there, and then you go to measuring resistance. You can't see the screen very well. Right now, it shows an overrange condition, and that's not a bad thing when you're measuring resistance. You don't want to see an overrange when you're in this mode or in this mode. If you see an overrange in either of these, then you've got too much voltage, and you may blow up or at least blow the fuse. But when you're measuring resistance, overload is good if it's open. And then we have a little diode continuity checker down here. Temperature, you need to have an external thermocouple, and we have those here. We don't have. I've never used them here in the lab. I mean, I've used them at work. I've used thermocouples at work. We have them all the time. We would use them all the time for measuring temperature. I've never used one here in this lab. And then you go to current. Now, when you go to current, you have to switch this input to this over here. And now you can measure current. If you're going to go higher in current, yeah, 20. If you're going to go higher in current, 20 amps, then you have to switch it over here. We're not going to be measuring 20 amps. I can guarantee you. It's too dangerous to handle those types of currents. And then the same with the AC amps. These are AC amps, and then back to off. So this is the device. I mean, part of this exercise is to teach you how to use this device because we are going to be using it throughout the semester. Now let's go back to the screen share. Where is? Oh, here it is. Why did it go way down there? Okay, so basically, I've just run through this first page. Here are some of the symbols. I have a PDF of the user manual. That I got these out of the user manual. If you want a copy of the user manual to study on your own, we're not going to study it here in class other than looking at these few things. you're welcome to request, and I'll send it to you. I'm not gonna overload your inbox with a PDF that you don't want, but if you want it, request it, and I'll send you the PDF for the multimeter. Now, these are some safety measures. I'm gonna read them just because it's good for this lab and other labs that we'll be doing. Never apply voltage or current to the meter that exceeds the specified maximum. They have a little fuse. I've never seen one of these burn up, but I've seen the fuses burn up and they stop operating, and you have to take it apart to replace the fuse. Use extreme caution when working with high voltages. The power supplies that we use, they only go up to 30 amps, and I wouldn't recommend. In one of these, I asked you to go up to 15 amps. I said they only go up to 30 volts. I misspoke. 30 volts, 30 point something volts. I wouldn't. In one of these steps, I asked you to go up to 15 volts. I think for most of these measurements, we can use 10 volts, and that should be good for most of our uses. Do not measure voltage if the voltage on the COM input jack exceeds 600 volts above earth ground. What that means is that's floating. If you look at your receptacle, there's two prongs, and then one underneath. That's the ground. Sometimes in certain circuits you don't have that ground, so you're floating. So that's not really anything to be concerned about in this lab, but it is something to be cautious of. 600 volts above ground, it's dangerous, and you shouldn't play with it. Never connect the meter leads across a voltage source while the function switch is in the current, resistance, or diode mode. Doing so can damage the meter. Always discharge filter capacitors and power supplies and disconnect the power when making resistance or diode tests. We're gonna one of the upcoming labs is going to be the RC time constant, where we will be charging capacitors, and we will discharge them just by putting a lead on them. You have to be in this lab. We don't have large capacitors. There are some capacitors that can charge up pretty high, and it could be dangerous to discharge those, but not in this lab. Always turn off the power and disconnect the test leads before opening the covers to replace the fuse or battery. You probably won't be replacing the fuse or battery in these. That's up to us to do. Never operate the meter unless the back cover and the battery and fuse covers are in place and fastened securely. Just some other things, if you want, there are little holders on the back here that you can use. One of these is kind of wonky, but like let's say you don't have enough hands, you can use this to hold to touch a particular probe, and then use this one to touch it. That's just a little aside. It does have a little stand that you can put this down and use. Let's see. So very important paragraph here. Before activating your power supply, before turning it on, I want you to let me check your circuit, especially the last one. Not so much the voltage and the resistance measurements, the first two measurements we're going to be doing, but when it comes to the last one, let me check your circuit before you flip that power switch on. Okay? So before activating your power supply to any circuit, please have your instructor, that's me, approve the circuit wiring of your setup. A simple error made to the circuit could damage the components or measuring devices. By convention, the red probe of the multimeter is used to measure the positive voltage or current, and the black probe is used to measure the negative voltage or current. The red receptacle of the power supply is the positive DC source. I have that. I just added that. That's one of the things I added. I revised the drawing that I sent you because I had the plus and minus reversed. I think y'all are smart enough that you can figure out that the red is positive, the black is negative. You control just like a volume on a radio or something like that. You control the amount of voltage with this knob here, and the current. This is kind of a current limit. Right now, you can see there's a little dot right there. It's wide open. It's wide open, so there's no current limit. There may be situations where we want to kind of turn that down, and I'll demonstrate that. That if you set the current limit, see this little current limited, that little red light will come on that says, okay, you're drawing more, or your circuit wants to draw more circuit than I'll allow. So it's just kind of a safety measure, the current limit. There's the on-off switch. It's in the on position. You can see the 10 volts. It's set for 10 volts. And these are auxiliary wires. You can use these. They don't even have one for the 12 volt. I don't know why. So let's get back to, where was I? I think I was here. Yeah, the red receptacle of the power supply is the positive DC source. The black receptacle of the power supply is the negative DC source, also called ground. If you look at some buildings, they'll have a sharp pole on the edge of the building. Anybody know what those are? Those are lightning rods. They're meant to attract lightning to those rods, and they're hardwired to the ground so that the lightning will strike the rod and go straight to the physical earth, and not to the circuit in the building. I've never looked around. I know where I used to work, you would see the lightning rods on the edge of the building. I've never really looked. I'll have to look next time, and it's too dark right now to see. But look to see if they have lightning rods, and they most likely do. Okay, so we went through this. This is the first exercise you're going to do. Set it to 200 volts, and then you're going to measure. You're just going to set it 5 volt, or I forget what I have you started. 5 volts, measure it, and just measure, okay, is my meter the same as, does it give me the same reading as the power supply? It might give you 4.9, this might give you 4.99 when that says 5. Which one is right? You don't know. Unless this were calibrated, and they have what they call Cal Labs. Every different instrument that we use is at Southwest Research. They had an expiration date. The equipment had an expiration date. When you reach the expiration date, you return it to the Cal Lab. They had the equipment to certify that yes, if this is reading 5 volts, it's reading 5 volts. And so you had to take it to the Cal Lab, and then you'd return it, and it'd have a little sticker that says certified. If you used equipment that wasn't certified or was out of Cal, and you reported it, you could get in trouble for that. In other words, you're reporting to the customer that, well, I checked this, but if you're using equipment that's out of date, then it's really not a valid check. Here, this is a teaching lab, so it's not really that important. You don't know whether the meter is correct or that's correct. All I want you to do is, if there is a difference, note the difference, do a % difference. Then you repeat the same step for a voltage of 10 volts and then a voltage of 15 volts. And that's all I want you to do. And then you do resistance measurements. Let me take, stop the share, and I've got a couple. Oh, did anybody look at the color code? how to do the color code. I don't know if you can see this up there. It's orange, orange, black. So if you look at that table of the color code, orange, orange, black, that should be 3, 3, and 0. So that's a 33 ohm resistor. Orange is 3, and the black is 0. It's a multiplier of 0. 10 to the 0 is 1. So let's put this. I'm going to put this in 200 ohms, and I'm sorry that you get that weird image on the screen. I don't know that that's any better. Can you see that? Why is it making that noise? I guess maybe the battery's low. Oh, it's because I still have it. It's beeping at me because I still have it configured for the current, and that's why it's beeping at me. It's telling me that it's wrong. So now if I put it in here, it's no longer beeping. It had a little indicator up there on top. What does that indicator mean? Well, let's go back to our test lead connection error. See, that was a little symbol it was giving me up in the corner, up here in the corner, and it was beeping. Well, that's a test lead connection error. I had the lead in the wrong spot. I didn't intend to do that. It just happened. I made a mistake, and it let me know. That's why it was beeping. Now, let's see if I can get a good image. I've got lead on one side, lead on the other, and it's 33. Can you read that? 32.9, 32.9 ohms, and it's 33. Well, what is the black? You see, it's orange, orange, black, and then there's a gold. What does the gold say? Is that a 5%? Is 32.9 within 5% of 33? It is. It is. So it's within tolerance. I have another one here that's a brown, black, black. Who can tell me the value of that? Brown, black, black. 10. 1, 0, and then a multiplier of 10 to the 0 is 10 volts. So let's, I said 10 volts, 10 ohms. And can you see that? Oh, look, 10 ohms. I don't know if you can see it. Can you see it on the screen? 10 ohms. So that one's right on. That one's right on. So that's the resistance measurements. You're going to be doing those. And let's go back to the resistance measurements. You're going to pick 3 different resistors. First, a high resistor, so it should be, if it's between 10K and 100K, it'll be, the third band will either be orange for a 10K or a yellow for up to 100K. That would be like a 1, a brown, black, yellow would be 100K. Try to stick the ones with the orange band, and then you measure it. First, you read what's indicated on the resistor, then what the tolerance is, and then measure it and see the difference, and then measure the difference. So, and then you do one between 1K and 10K, and then you choose one between 100 ohms and 1,000 ohms. And that's all I want you to do is read the resistors. And then this is going to look a little different than your, because I added detail. I also had these reversed. I had the plus and minus to the wrong side. I was just going from memory and didn't, I put them wrong. So I added a little more detail. It doesn't matter. I mean, you don't, hopefully you didn't, I mean, if you printed it out, it's the main one to print out or at least copy is the data table. And I think at the time it was page 6. That's the one that I want you to turn in. If I have any questions, I'll make them like a little quiz on the submission page. Okay, I'll make a little quiz or something to, you can answer the questions there. I want you to calculate what you think the current will be. And for this example, I used 5600. You can see green, blue, red, gray. That's 5,600 ohms with a tolerance of, I think, 10%. Well, you can calculate what it is. If you're using 10 volts, 10 volts divided by 5,600 ohms is 0.00179 amps, which is 1.79 milliamps. That's going to look pretty small on a device like this. So I've actually decided we're going to use these other devices. This is a physical current meter. Now, this one, it doesn't matter. You know, if you put it in wrong, all you're going to get is a negative current as opposed to a positive current, which you were expecting. If you do it on this one, you're gonna peg the meter in the wrong direction. Most likely you won't burn it up, but again, have me check the circuit before you turn it on. Okay, have me check the circuit. But we're going to use these for the current. I think you'll get better readings from them. Let's see. So this is the kind of a hand-drawn layout of what it should look like. And this is the circuit diagram. You're going to have to get used to looking at circuit diagrams. This is the battery. I think I explained that in the lecture. These little squiggly lines are a resistor. The ammeter, it goes in line with the circuit. This is actually observing outside the circuit if you want. It's not really part of the circuit. It should have a high enough resistance that it doesn't affect the circuit. In this last, you'll have to forgive me for forgetting. This last chapter did not cover parallel resistors and series resistors, resistors in parallel and resistors in series, did it? I know the capacitors did. We've already discussed capacitors in parallel and capacitors in series. I don't think we've covered that under resistors. Resistors in parallel take like, let's just say this voltmeter that we had, let's just say it was 5,600 ohms. The meter itself had a resistance of 5,600 ohms. Well, then you would have a 5,600 in parallel with the 5,600, which would cut the resistance in half, which would give you a much higher current than you're expecting. But typically these have a does it give the under the specific? Oh, this one doesn't, or it does. Let's see. It doesn't give you the the internal resistance. It should have a resistance in the megohms, a very, very high resistance. Okay, I think that's it. I tried to explain what I wanted in pretty much detail. Oh, this is the data tables. So you use a I'm gonna have to change this because there's 5.0. That's an easy fix. 5 volts, measure the voltage, tell me the difference. Hopefully there's not much difference. Hopefully you measure 5 volts on the meter. Same with 10, the same with 15. From the resistance measurements, tell me what you read on the resistor. Like this one is 3 black, 3 red, orange, black. So that's 3 with a multiplier of 10 to the 0. That's 33 ohms. So I would put down 33 ohms in the indicated resistance. Then you measure it. What did I measure with this one? 32.9, I think. 32.9. The indicated tolerance is the gold, I think, is 5%. And then tell me the difference between 39.2 and I said 32.9. I reversed the digits. 32.9 and the 33 that's indicated on here. And go ahead and use the meter as the accepted value. And then for the current measurements, I want the supply voltage, the indicated resistance. Use the same resistors that you used up here, so that you can just transfer the indicated resistance here and the measured resistance. You can just transfer it to here. Use the same resistors. Don't use the new one. And then calculate your current using this little current equals voltage divided by resistance. Calculate what you think the current should be, and then measure your current, and then give me the percent difference of the current. The percent difference, I can even add that. Let's see, LaTeX and where's I'm going to fix 2 errors. Oops. I'm going to take off these zeros because we don't have that much resolution. So and down here, percent difference. Current. So there's no confusion. Hopefully it doesn't mess it up too badly. Let's look at okay, it made it bigger than I wanted. I'll fix that later. If you understand what I mean. Oh, I put it in the wrong place. There it is. That's where it should have been. Percent difference of the current. That's what I wanted. Okay. And do I have any programmers in here? No? No programmers? Because this is all, LaTeX is just it's a typesetting language, but it's basically programming. And this is how I generate these instructions. You'll probably see more of them throughout the semester, since we're not using the lab book. Any questions? No? Okay, there's 5 of you. I've got 3 stations set up. Probably only use 2 of them. If somebody wants to do it by themselves, that's fine. In the meantime, I'm going to try to correct the error that I did last week. I didn't measure, or not last week, 2 weeks ago, actually, on the, when we were doing the circle. I didn't do that. I did that incorrectly. So I'm going to try to fix that, but I'm available if you have questions. And when you come to the current measurement, let me check your circuit before you turn it on. Okay? Yeah. I think all of these are set. Oh, let me turn this off. Signing off on the Zoom. Can't even think.